Welcome to this new format. Uh, we just happen to call it the Wireless LAN Professionals Forum, but really it's just a chance for us to get together with some experts and talk. This one's on Wi-Fi 6E and 6 gigahertz design. It kind of came about because Chuck had posted a couple things on Twitter. They had some feedback back and forth, and he came up with the idea instead of blasting away at 140 characters at a time. What if we got together and had a little discussion? So we put together a little panel here, and we're going to have a panel discussion today. We could do introductions, but you know everyone who's on the panel today. We have Chuck Lukaszewski, Lee Badman, and Peter MacKenzie. Let's talk about how this is going to work today. First, we're going to shoot for about 20 minutes per topic. We have 3 questions that we're going to cover. They don't have to fit exactly inside 20 minutes. We'll go as long as the discussion goes on. One panelist will talk a little bit about the idea, and then the others will kick in and we'll comment and have kind of a discussion like we might have at a bar after a WOPC event, talking about some issues. If this technique works, we'll try it again another time. So let's just jump straight into the first one. And the first topic is the one that triggered all of this with Chuck's post on Twitter about in 6 gigahertz, what size channel should we do? 20, 40, 80, 60, 130, 320s, some crazy number. So Chuck, you want to lead us in and tell us what you think about 6 gigahertz size channels?
I would be happy to, and good morning, good evening to everybody. And thanks, Keith and Lee and Peter for being willing to jump in the pool here. So yeah, I guess it's a good thing I'm on Twitter now. So let me, if you don't mind, let me take the screen and let me set the stage real fast. By showing a slide that some of you have probably seen. But I just want to convey, we've learned a lot about channel widths over the last few years, and of course, I'm one of the principal advocates, as I think everyone knows, about using narrower bandwidths in higher density environments. But let me just kind of do a quick level set. So I know this is probably old hat for the audience, but just so we have a common terminology. So when we have more channels available, we have more distance, more linear distance between cells that are on the same, that are co-channel with one another, and that have to defer to each other, and that has a bunch of different advantages to it. And of course, that is why most networks, most enterprise or managed networks run narrow today. And so even though in 5 gigahertz, for example, we have depending on the country, anywhere between 4 and say 6 80 megahertz channels. And I'll show you in the next slide. Very, very few people actually run those bandwidths, and the reason is because the goal is by increasing the reuse, we sacrifice essentially the peak data rate, right? Because we cap the burst rate, but we improve essentially the noise floor in the environment, and so that allows us to absorb more load. And just as some interesting research on this, so on both, I'm just going to, in the spirit of the ad hoc here, I'm going to present both Cisco and HPE data. So we published some results as part of our submission to the Canada 6 gigahertz consultation that just wrapped up. And this is data from our central system. And this is probably none of you have seen this before, but I asked the central team, okay, how widespread are 80 megahertz channels today? And you can see the result. It's 9% of this is our North American customers on Central, and about half the users are on 40 megahertz and 40% on 20 megahertz. And this data does not include any large venues. It does include some universities, but no airports. Cisco has found much the same. The citation is here, but this is some data that they brought to IEEE as part of the Wi-Fi 7 discussion, and you can see that they, broadly speaking, are seeing the same thing. And so, the rationale for why we do this, and then what that means to 6 gigahertz is kind of just on this brought up, so if we look at the band, And I'll stop here and leave this up for the discussion. So if we this is a U.S. versus Europe comparison, and you've all seen this for me before, right? But let's just imagine that the bottom part, this is 5 gigahertz, not 6 gigahertz, right? Because it's approximately the right number of channels. And you could just literally see that there are not enough 80s to do the job. We have 12 40s, and that's why that's the dominant bandwidth. So up here in 6 gigahertz, we have more 80s than we have 40s in 5 gigahertz, at least in countries that do the whole band. And so right away, the argument I made on Twitter, again, just based on our experience and so on, is that basically 80 is the new 40 is sort of one way to think about it, right? In other words, if the logic that got you to 40, if you apply that same logic to the new band, then 80 will give you an equivalent reuse experience. And that kind of means that you can just draw the analogy forward. And I do think that there are some customers, some network users that 7 160s is more than we've ever had 80s in the 5 gigahertz band. And the line between, okay, how many channels is enough in the repeating channel plan, it's very subjective. It varies from deployment to deployment depending on what's in the walls and so on. But I think 7 is very definitely in the zone. It's the lower end of the zone. But we definitely will see some customers that start with 160. I think 80 will become the dominant bandwidth in this band. So I'll just stop there. That's essentially where I'm coming from with the argument.
So Chuck, what I was saying is, given the current state of client devices and how they're all over the place for capabilities and implementation, do you see anything going forward that's going to somehow make that condition any better? Are device makers going to somehow be influenced to kind of be more uniform with their approach to stuff with 6 gigs?
Yeah, that's a great question. And by the spirit, for the audience is, we're looking to have an animated discussion. So, don't take what I'm saying as gospel necessarily. So what I can tell you, I mean, having been, the major silicon vendors have been part of the 6 gigahertz advocacy group for, going on 5 years now. And I can tell you, and having worked with them for that long, while it's absolutely true that the driver support is kind of all over the map in 5 gigahertz, that 160s, and actually, they're in a lot of their advocacy, they talk about 320 and Wi-Fi 7, because of course they have to look years in advance, right? Much further in advance than even we do as a AP manufacturer. And I can tell you, it is absolutely my expectation that any 6 gigahertz capable client device or module will absolutely do 80s, and I would be shocked if they didn't do 160 in 6 gigahertz dependably.
Just for context, we're talking smartphones, we're talking laptops, we're talking IoT. What are we talking and what are we not talking when we talk about devices that are going to be in 6 gig? Or do you foresee everything? And the reason I'm asking is obviously battery is going to be of concern and all of that. So do you see any haves and have-nots as far as, suitability for 6 gigs at this point?
Yeah, Lee. So that's a really important topic. So the channel widths will vary, right? And I guess we should pull in here is that with ofDMA and with just Wi-Fi 6 generally, right? We get the ability to subdivide whatever the bandwidth is in the channel, right? And so, for example, you probably know, I don't think there are many clients that do this yet, but in Wi-Fi, in AX, there's a mode called a 20 megahertz only station. And to your point, that was created for primarily, I think, wearables, right? It was the consumer electronics companies that kind of pushed for that. But it's any kind of IoT device, right? At the end of the day, you want to use as little energy as possible to send what you need to send. And so the standard already allows for a device to use a piece of a bigger channel if it so desires. And like I say, there's at least a couple different mechanisms that are set up to do that. The other thing that's coming, and it's it's in AX. I don't know how widely it's deployed right now, but in 6 gigahertz, I can tell you that we've talked a lot about it for maximizing bandwidth. Is preamble puncturing, right? And for those of you that may not have heard about puncturing, that's the ability to notch out any 20 megahertz subchannel within, let's say, an 80, for example, or a 40. And why would I want to do that? Well, one reason is if I normally want to run a big channel, but there's an incumbent nearby, and I'd have to give up the whole 80 if that was my only option. Puncturing allows you to run the wider channel width in general, but the APs that would be subject to, that would have to protect that incumbent and couldn't use, let's say, that given 20, they can just not transmit on that subcomponent. So again, the trend in the technology is to be able to mix and match dynamically bandwidth, specific frequency ranges on a packet by packet basis.
A couple other issues I wanted to bring up on this same discussion. One was, Chuck, you mentioned you had data from Cisco and HP on 40s versus 80s versus 20s, and there's still a lot of people still using 20s. That's like almost half. And I'm guessing a lot of the 40s are there because someone misconfigured something or let the automatic stuff automatically do it because it sounds better. I'd like to see if anyone on the panel knows any stats on, if you go to 40s in a lot of environments today, do you still have Coachella interference, which I think is a lot worse than having a smaller channel? And if that's the case, taking the idea that people are already using 40s, so and it's working, that'll work in 6 gig. I just haven't seen the data that shows 40s are actually clean today. Does anyone have any top ideas about that piece?
Well, I think it comes down to all these discussions, and I hope this answers your question, Keith, but maybe it won't. But trying to say that a certain channel width is normal or will become normal, I think is as dangerous as saying you should put one AP per classroom or you should place your APs in a certain location. With Wi-Fi, we designed to the requirements. And I think a lot of these discussions come down to that one issue, is that we need to design to requirements. And what is the correct channel width will come down to what the requirements are, what the density is, what the environment is like. And I think that's really important, especially when you think about why do we want more spectrum? I think when you look at everybody goes, we want more spectrum. Well, why do we want more spectrum? And once I've got it, what am I going to do with it? And as far as I can see, I think there's two approaches to how we use more spectrum. We can either have more channels, is one approach, or we can have wider channels. That's what we can do with more spectrum when we get it. So which do we want? And why do we want more spectrum? Is it because we're trying to get wider channels, or is it because we're trying to get more channel and more spectrum reuse? And clearly in some environments, I remember I helped design a very, very large convention center where in one room there could be 10,000 devices, 10,000 people. And there we just don't even have enough 20s, let alone enough 40s. So actually I want more 20s in that type of environment, in a stadium environment. So again, it's down to requirements. Now, what about the requirements where you've got, and this is coming to Keith's question, let's say we've got an environment and I'm using 40s, 5 gig 40s, and I've designed it so I'm using all the 40s with, let's say I've managed to do it with no co-channel interference, but I'm, in terms of channel reuse, I couldn't get any more. I'm using all the 40s in the 5 gig. Then the question comes, if I then introduce more spectrum, so I've got 6 gigahertz, I've got two choices. Do I want to have even wider channels in that environment? Let's say I've got 40 devices currently connected to each 5 gig radio. So do I want to have 40 devices now connected to an 80, so they've got a bigger chunk of the spectrum to share? Or do I want to have more channels, more 40s as opposed to, and have 20 devices connecting to each 20. Now, of course, that would mean twice as many APs. So I know that there's obviously budgetary concerns here, but which is better? Is it better to have less users on more channels, or should we be going for more users on wider channels? And I think that's where to me, where this discussion hinges.
And I agree with you. I think that whole discussion you just had is totally relevant, and it's all about requirements. But one of the other things we should think about, and both Germans and Chuck both have calculators you can go and put in and say, of the whole airtime, how much is being used, and or when we use spectrum analysis, we can see visually that the full 80 or the full 40 aren't being used nearly as much as the primary. So I think it's more efficient to use a smaller one and fill it out. But it would be nice if we had an actual tool that could tell us, in this scenario, you should run blank.
Yeah, I agree. And I think when I've ever done an experiment in the 5 gig and I've had, a number of clients over a wider channel, and you push throughput, say, from 2 clients even on a 20, and then I split up on a 40, and I split up into 2 20s and have APs using different channels, you get more aggregate throughput using the smaller channels, I think. Given, does it get to a point when actually we can use wider channels and still have channel reuse? I would have to be yet convinced that it's better to use wider channels, I think.
Yeah, so if I can just jump in, and I know we're coming up to the end of this segment, and there's no wrong answer here, right? I guess let me just start with that, right? I mean, I assume everybody that's on this call or most people on this call are engineers, and you're supporting, you're doing design work or troubleshooting or what have you. We're gonna figure this out over time, right? Just like we have in the other bands. I think we can all agree that 20 megahertz is the right bandwidth for 2.4 gigahertz. As one of the people, who is strongly associated with the 20 megahertz channel, right? Let me just, again, I'm hoping the nuance is coming across here. It very much does depend on requirements, and it depends, so one of those requirements is, what do you expect as sort of the typical, when you have devices that are bursting in the environment, for example, what is a good target speed for that environment, right? If you're doing, for most enterprises, right, I mean, a narrower bandwidth is probably fine. Of course, everybody, loves to do a file transfer, or, get the print job off faster, right? But if you're doing VR or something like that, you could be looking at, easily, 20 to 50 megabit per second sustained streams, to a single device. And so, clearing the air quickly starts to become important in that scenario. One of the places where I've, over the last couple of years in working with the LPV team here, my own thinking has changed on this. Let me just differentiate between 2 different large venues to kind of let you into kind of how I think about this. So in the stadium environment, 20 is absolutely, to this day, remains absolutely the right call, because when you have an event, and I'm talking about 5 gigahertz now, right? So I'm hoping that we could go to my intention anyway is to start with 40 in stadiums as we go to 6 gigahertz and see, kind of to the point of the questions that have been asked here, does the 40 perform at least as well as the 20 from an interference and a packet, retry perspective? And then, to the extent that we're clearing traffic faster, we're clearing the air faster, right? Are we able to absorb more load? And a stadium, of course, is always full, right? So you're always, anytime there's an event, or it's if it's not to capacity, it's got a lot of people, right? Let me contrast that with an airport. So one of the things that has become, we're deployed in a lot of airports around the world, and airports are scored. They're not like stadiums, right? So you get these big crushes, immediately before a flight, but most of the day, it's actually pretty lightly loaded environment. And so if we go with 20 megahertz channels in an airport, more of the time of users is spent butting into the peak data rate, right, for the channel bandwidth than dealing with surge capacity when there's a high density experience. And so we've been actively playing with much wider bandwidths in airports and using dynamic bandwidth selection. In theory, if dynamic bandwidth selection works properly, right, and it's implemented on the APs and in the stations correctly, and we distribute the 20s, the primaries, as folks in the community have read, there's some good authors on this. Andrew Von Nagy has written, I think, good pieces about this. In theory, when you get that big crush, the network will collapse to a distributed set of 20s, right? But in the meantime, you're running at 40 or even 80. And so the burst rate that you'd experience during a more idle period is a lot higher. So back to the point about requirements, I don't think of an airport anymore in the same, in all the same way that I think of a stadium.
I think that's great. Just a couple comments from the chat window. And I agree with this. When we get to when ofDM-A actually is working and we have supported clients doing it, it might solve a lot of these issues as well. And so thanks to those who put that in the chat window. How about if we move on to the next topic? Peter, you want to give us just a quick lead in on the next one?
Yeah, absolutely. I think the next question was, what is the sort of discovery process? How can clients find 6 gigahertz access points? So I guess really, obviously, as people know, I live in the UK, and we only have a small amount of spectrum coming in the 6 gigahertz band. So this isn't really my problem. So it's a US problem. No, I'm not going to say that. But what is the problem with discovering APs in the 6 gigahertz band? Well, if we consider, let's say we are using 20 megahertz wide channels, and let's say you do have 1.2 gigahertz of spectrum. Not that I'm jealous with only getting 500 megahertz in Europe, but let's say you do. That gives you 59 20s. And the traditional approach of going around each channel and scanning every channel, especially after you've already done, let's say you've done 2.4 and 5 gig channels, and probing out on every channel is just going to take way too long. In fact, you can argue that just scanning all the 2.4 and 5 gig channels takes a long time. Today, for a roaming client, it causes actually quite a lot of issues. It does today. I don't know if you've ever looked at roaming. It's why we've got things like 802.11k and V and neighbor reports, which help roaming clients speed up that process already. So if you add a bunch more channels in there, you're just creating a bigger problem. So there's a number of mechanisms coming with, in 802.11ax and in 6 gigahertz, which is aiming to help alleviate that problem. And some of these methods I think are probably quite useful. Some of them might be less useful. And there's going to be what we call in-band AP discovery methods and out-of-band AP discovery methods. So if we're looking at the in-band ones, these are ones where it's possible to actually scan and probe out on the 6 gigahertz band. I think these methods are only going to be used for sort of single 6 gig single radio devices. So maybe you've got a tablet and you're tethering it and it's becoming a 6 gigahertz AP. It doesn't have a 2.4 and a 5 gig radio. So all the discovery has to happen in band. And the way this is potentially going to work is we've got these preferred scanning channels. So clients will only probe out on the preferred scanning channels. It's like every 4th channel across the 6 gigahertz band. And that will enable, when you're setting up your AP, your tethering AP, you will use one of those 20 meg channels as your primary channel so that the APs will answer on one of these every 4th channel. So you can just get through the band quicker. The method that I guess is probably going to be mainly used is for Wi-Fi APs, which will likely be tri-radio, so 2.4, 5 gigahertz and 6 gigahertz radios, is going to be, there's going to be a couple of what we call out-of-band methods. And this is where your clients will still probe out, but only on the 2.4 and the 5 gig band. They just won't send probes on the 6 gigahertz band at all. And what they will do in that scenario is they will, when they probe out to the 2.4 and the 5 gig radios, in the probe responses or also in the beacon frames, which they can listen to, they will be what we call a reduced neighbor report. If you're familiar with K and V, it's quite similar to the neighbor reports, but it's just compressed. So it's taken up less space in the packets, and it's a little bit more efficient, which will tell you about the 6 gigahertz radios. So you learn about the 6 gigahertz radios from your 2.4 and 5 gig probes. So I think that's, hopefully will make things faster, hopefully will make things better. I think with all of these methods, I guess probably maybe this is a point for discussion. Maybe Chuck may want to come back and explain a bit more, but there seems to be a lot of options. There's the in-band discovery, out-of-band discovery. And some of my questions is, well, will clients try and do all of them? And is that actually going to, where we've seen lots of options in standards in the past, that's sometimes led to inefficiencies. And also, if I'm, something that, again, Chuck may know, I've got a question on this is, let's say we're doing out-of-band discovery, does that work across SSIDs? Because obviously, Chuck's on, I'm hoping it does, but if it doesn't work across SSIDs, I see issues there as well. If you've got a 6 gigahertz only SSID, as we often now like to have 2.4 only 5 gig SSIDs, will the discovery work across different SSIDs, or will you have to have the SSID advertised on all bands? So that's my summary, and that's where some of my questions is. I'll allow somebody of a panel to come back.
I know after all that being said, Peter, and then I'll get my rant out there, and then I'll relinquish to Chuck or Keith. All of that being standards based sounds great. My one fear for 6 gig is like with band steering and all of these optional non-standards based things. Different vendors come up with their own magic, which breaks things. It's already going to be complicated enough. I kind of hope we can stick to the standards, and that's what prevails, as far as all of this stuff goes. Otherwise, it's just going to be, more of the same in a different frequency. And I hope we've learned lessons from the past that, the proprietary stuff, although it's very marketable, it also doesn't work most of the time or a lot of the time. So.
Yeah. So, and Lee, I think, I would be foolish to try to deny that. I think we all know that with every new generation, right, there's a period of time where the clients have to catch up, right? The AP manufacturers come out first, and then the clients hit the market, and then the WFA certification does a lot, but it is not, it doesn't do every possible corner case. And the beauty of Wi-Fi is you can mix and match any client with any access point, any combination, right? And so it's impossible to get it all right in advance, and it does take time to flush out the kinks. And honestly, I think 6 gigahertz is going to be no different. And the fact that we're trying to span bands now, right, as a critical part of the workflow, is I'm sure going to be not without its challenges. Although, to that point, the 6E certification does specifically test these discovery mechanisms because they are so critical. But to Peter's point, so just here's a PCAP, and I've showed this. You might I've flipped through this quickly if you've seen any of my 6 gigahertz talks, but here is a beacon. This is a 5 gigahertz beacon, and you can see that this is the reduced neighbor report, or RNR. And you may have heard of neighbor reports, but RNR is something it's been around for a while, but it really hasn't been used until recently. And so again, Lee has a fair point here. Anything that's not not well tested, may have may be suspect. But basically, the way this works, so it's not many bytes. You can see it's only 17 bytes to start with, and the idea is that in a multi-radio access point, each SSID virtual AP on each radio would be advertising this. So if you looked at the 2.4 band in the beacons for this SSID, you would see the same IE listed. And you'll notice that the SSID name is not in here. And the reason for that is that this value, when this is set to 1, it just means see this information element so that we don't have to duplicate that material in here. Now, if I'm running multiple VAPs on a radio, I would then have to have this, each beacon would have the RNR in it. And of course, that would be replicated, across the different bands. And then this is the pointer, right? This op class 133. If you don't know what op classes are, it's kind of an obscure part of the standard, but there's an appendix at the end of .11, which has all the channel sets basically in all the different countries. And so these are the 3 op classes that apply to 6 gigahertz. And the reason you see channel numbers here, but not start-stop frequencies, and that's because that's all defined in the annex. But 133 basically means, okay, go to look for this SSID on 6 gigahertz. So that's how it's going to work. I think that this this is a required mode, and I think this is going to be the dominant mode because the other out-of-band discovery method is the multiple BSSID beacon, and that's even less tested, right? That's been around for a longer period of time, but I'm a huge fan of the MBSSID beacon because it allows us, for those of you that don't know what it is, you can basically pack multiple virtual APs in a single beacon, and that saves airtime, right? I don't have to have lots of beacons in repetition with one another. But the struggle we've always had with that is, okay, how do we migrate networks that are using separate beacons for different VAPs to a multiple BSSID context? And there's just never been a good, easy way to get that done. So I'm a little skeptical. I mean, right now I still don't see how we get there. So I think this RNR method is probably going to be the default you'll see from most manufacturers.
So just to come back to you on that, if that filtered is set equal to 0, does it then, how does it communicate which SSID it's referring to?
I am embarrassed to say I don't know the answer to that question.
And that's fine. That was just one of my questions, was that, at the moment, the best way to steer clients to 5 gigahertz, because we can't really trust clients to behave themselves, is a 5 gigahertz in the SSID. I'm assuming we may want to do the same thing on 6 gigahertz. So if we do that and have a 6 gigahertz only SSID, then how does, my questions is, how does this work for 6 gigahertz only SSIDs?
Well, so you don't need so I don't know all the values of all the flags and what they do, but I'm happy to follow up on it. But in 6 gigahertz, there's no need for the RNR potentially, right? At least for 6 gigahertz discovery. Now, you might display it anyway to give people, to let a client know that there's a 5 gigahertz or a 2.4 gigahertz radio available on that device. But if the device has made a decision that it wants to scan in 6 gigahertz, I think it's going to follow a different workflow altogether, right? And that's what you talked about some of the other discovery mechanisms. So that's the preferred scanning channels. And thanks again to Twitter. So this, I'm sure in the comments, people have already commented that I showed the wrong channel plan a minute ago. So this is the correct channel plan with the preferred scanning channels that Peter was talking about. They are set in, they are 20 megahertz inside. So it's it's the second 20 inside the wider bandwidth, right? So 40, 80, 160. So if you're a station and you intend to discover on 6 gigahertz, you're most likely going to either probe on one of these PSCs or listen on one of these PSCs, or you're going to use one of the other methods, which primarily involves passive scanning for one of these Phil's discovery frames. And which I've seen demonstrated in packet captures, but again, I don't know what's going to become prevalent.
So I can't help but look at this and think if we ever do get back to an in-person WLPC, all the great sessions that are going to come out of just this. But
There definitely is a lot going on here, and it's still we're talking about things that don't really exist yet, but hopefully they will soon. A couple of people have been testing some Netgear gear. Any idea, and this isn't just for Chuck, but anyone know when enterprise gear might start shipping in the 6 gigahertz range?
I could tell you, but I'd have to kill you.
how about you tell us and we pick somebody else you can kill?
So what I've said publicly, I would be surprised if you don't see, every one of the major manufacturers with at least one product before the end of this year, this calendar year. We've already got the consumer products out, and enterprise typically follows by 6 to 9 months from that mark.
How about if we transition now, Lee? You want to take the last topic, which is about I don't know if it's a sore spot or just a place people like talking about using multi-gig switches if we're going to Wi-Fi 6 or 6E.
Well, that's a big and contentious topic. And then the other one, the other wired side infrastructure issues. So down there, talking about PoE and such. But, if you start with PoE, it's interesting. We'll see what the APs demand for power. And, we tend to talk about PoE singularly, how many APs can it support? But I know, more and more with voice over IP and cameras and all of that, you got to kind of look at your PoE environment holistically. So it'll be interesting to see what these things do, what the APs do to add to the power budgets. And I have no clue. But I'm just, conversational marker saying it will be interesting. As far as the throughput for multi-gig switches, all I can say as we get into this is, at long last, I hope we need them. It's always we've been doing this for years. It's almost like a vendor provided TCO study and how much darn money you're going to save by going to this system. And then the next vendor comes along and shoots holes in it. Just the different sides of the argument and the different metrics people put up and the math that they cite with such conviction on why you need to go, above a gig for a uplink port and all of that. I really and truly hope that at long last we do need multi-gig switches. Otherwise, all the marketing of this stuff is kind of like, how long can we continue the facade of how much throughput we're actually going to get on this generation of wireless that never materializes. So, I'll just leave it with that and, let you guys chime in. But, and I'll say, man, I hope so.
I kind of asked you, Lee, about this because you run a very large campus network. And I was just wondering what kind of numbers you're seeing in pre-6, just Wi-Fi 5 going across your switches. Are you running into a need today?
We are not that I've seen, but we're also running mostly 20s with some 40s. So that kind of containerizes and caps some of what you're ever going to get. Where we have our widest, I think the last time I actually bothered to look, I think we're seeing, a busy AP would be, I'm thinking around 400 meg, but it might be a little bit higher. And I can also say I haven't looked in a while, but I have looked, and that 400 plus or minus maybe 75 is what stands out in my mind as what I saw as a a busy AP. Um, so certainly not seeing them yet, but then, to your point about running a large network, you've also got to play the guessing game. You can upgrade your switches depending on your budget cycles. Maybe you have to upgrade switches today that you can't touch for 5 years, but you're going to do something different with wireless in 2 or 3 years. So that's where you got to kind of read the tea leaves. And even if you don't need it today, depending on how you do your upgrades and your replacement cycles, you might have to guess and hope that you can find something beyond just pure marketing that wants to sell you these high bandwidth switches, and find something that says, okay, we're going to need them, and this is why, because we're 3 years into this switch replacement cycle. We're going to put in these APs, and clients are going to magically show up, and we're actually going to need it. Those are hard planning games to play. So there's the today, and then there's the near future that some of us have to guess at too, and it's really a thorny topic. But to answer your question, Keith, absolutely not seeing anything that's in my environment with how we do it that's pushing close to a gig today.
Well, you brought up a couple of really good points there, and the first was marketing numbers versus reality numbers. And that's why I put on the bullet here the reason for upgrading could have absolutely nothing to do with Wi-Fi. You're on a switch cycle and you're going to upgrade switch. Why would you not put in a multi-gig today? So I mean, there's a lot of technical reasons to do it. I just don't see the math as working out. And I've seen some posts that Chuck had done, and you can respond, Chuck, to this. But normally when I see the math, it's always at least an 80, maybe a 160 meg channel. And we know that we can never go any faster than a single client on a single AP. That's the fastest we can make Wi-Fi go, because if we have any more, then there's the contention loss. And the numbers are also using 1024 QAM. And so I don't see either of those two things as being realistic. So any other talking about why do we really need it today?
Thanks for the discussion. I've been holding back because obviously I have a point of view on this, but first off, again, as we've said on the other topics, it's totally dependent on the use case, right? So, if I was deploying at a hotel, for example, and particularly if I've got an AP per room or every 2 rooms or what have you, I mean, it's a gigabit is plenty, right? You're unlike, for all the reasons that Lee mentioned. Right. But if I'm in a university and I've got, or at least some parts of a university, right? Maybe the dorms, maybe the lecture halls, and I'm consistently running higher loads on my APs, then maybe it makes sense to do a more targeted, type of approach there. And I think that's the key, because you can kind of mix and match. The only point I've been trying to make is, it's been hard to really justify smart rate, which is what we call it, right? But 2.5 gigabit or higher for APs historically, because if you're running narrow channels, right, you can't get, I say this in all my talks, right? You can only get to 900 megabits PHY rate between the 2 radios with the usual channel sizes, and so. It's difficult to look a customer in the eye and say, well, you really, you got to have, something faster than this. But all I'm trying to educate the community on is that with the 6 gigahertz radios, I mean, there is a immediate, credible, out of the box path to much higher burst speeds coming off the radios. But I would also say, right, it's more important. Like if you have $10 to spend, right. It's more important that you spend those $10 on getting tri-band or getting 6 gigahertz in your environment. Catch up with the switch ports later, right? I would do that instead of upgrading the switch ports and buying the APs later, because the APs are close enough. But I think as a best practice in a campus environment over the next few years, I do believe that people are going to migrate to at least 2.5 for ports that drive other infrastructure. And we also should be cognizant. I guess I'd be interested in what you all, you're closer to this probably than I am, but we have this running thread about using PoE switches as power supplies, right, for lights and IoT devices and everything else, and cameras. And to the extent that 60 watts is a separate line of drivers for some companies to look at upgrading the switching infrastructure, that would be another reason to look at that investment.
So one thing I would say, just to dive in on this discussion, would be as someone who does a lot of protocol analysis of people's networks and very often looking at traffic behind access points, I would say the vast majority of traffic I see behind, let's take out lab testing and doing throughput testing with lots of clients pushing as much data as they could. But in real client environments, even busy APs, the throughput currently today that I see is typically very low, often below 100 meg being pushed across a given access point. So some peaks up to 200-300, but the vast majority of time it's very low, and I think it's very low because you're looking at only at ever one time generally a single user's worth of traffic, with it being a shared medium. So I would have to see some hard evidence of a real environment to see any need for it at the moment, because I don't think that sort of traffic volume is being sent over Wi-Fi today, especially not in enterprise class networks. Another thing I would say on it is, well, let's say we have 5 gigabit ports to an AP. Where's that traffic going? There's a general move in the industry to more cloud, applications in the cloud, data storage in the cloud. A lot of traffic's going external, or at least to, even if it's a private cloud, it's a private data center that's not on the same site. So what is the customer's capacity out to the internet, out to that cloud? A lot of customers, maybe the maximum some customers have is a 10 gig internet pipe, sometimes a lot smaller. Some maybe have. So if I'm worried about every AP doing 5 gig, well, there's going to be a bottleneck somewhere on the network anyway, which is going to start to reduce that traffic. So even if over the air and over that Ethernet switch port, I can get 5 gigabit, I'm not going to get 100 APs all doing that at the same time. I'm going to hit some sort of bottleneck somewhere else in my network. So I'm not. I see you can do the figures, you can do the lab testing, you can prove it's needed. I've got to bet I'm cynical on actually seeing a real world need in customers' networks today.
I think one of the comments that Eddie had made, and maybe Lee could answer this as well, and perhaps Chuck when Lee's done, is even in LPVs, and I know that you have some LPVs, that's where you need to push a lot of data. Are you seeing, higher or even close to a gig coming off of your APs and your LPV?
Well, unfortunately, the only LPV we have is not the greatest wireless design, so it crashes and burns, and I'll just admit it, long before we ever get to the point where we could ask, okay, if it was running efficiently, what might it do? But the answer there is a clear no. But one more thought is that, Chuck has a lot more experience, hopefully with good, well-designed LPVs, and I've seen a couple of them, so I'm guessing he's got more clarity on that. But I would say, switches, like everything else, evolve, and it would just be wonderful if, the higher throughput ports, the M gig, whatever, just, become commoditized and not premiumly priced, then you just get them as a matter of course, and it becomes a non-issue because that's just what comes next. Unfortunately, I don't think that they're going to evolve that way between the newfangled licensing and everything else, I think you're going to continue to have to ask the question, because a lot of times it comes down to price. Do we buy these new switches? If they were cheap, you wouldn't even think twice. You'd get them, and you just get the bandwidth and throughput and all of that as a matter of course. But because they are such a premium price, I think that alone drives the question of, should we be buying these? And it kind of sucks that you got to bring that into the discussion, but you really do. But anyhow, back to Keith's question about the LPV, and switch ports and utilization. What do you think about that, Chuck?
Yeah, so I'm really enjoying this conversation. Actually, Keith, I think we need to do more of this. First off, in stadiums, it's actually the opposite. So we have big loads, but they're very distributed, right? We've got thousands of APs in a 70,000 seat to 100,000 seat venue, right? You might have 400 or 500 APs in a 18,000 seat, a hockey arena, what have you. And they're running 20 megahertz. So they're capped in the channel size, and we're generating and the over-the-air interference, right, and spatial reuse is basically capping the data rate that you can achieve on each channel. And so in practice, in that type of LPV, you're talking about a lot of relatively small, right, creeks and tributaries that add up to this big river. In an airport, it's a different deal altogether, right? It's possible to generate. If I'm at a gate, one of the things that we're asked, so basic customer expectation in the airline industry, right, is that we have to be able to support very rapid, Netflix downloads at gates, and I'm looking forward to flying again here, hopefully in the near future, right? And so burst rate really becomes important there, the more we can retire quicker, right, the faster we clear the channel for somebody else. And then if I go to the a clinical environment, clinical environments have lots and lots of devices, but not necessarily really pushing the pedal to the metal, right? Unless I'm doing medical imaging or something. So again, we've said this a bunch of times, but it's very much dependent on the use case. I'm just, again, trying to educate, customers. I feel an obligation to at least come out with, provide the information. And so because dimensioning is a basic part of what we all do, right? So you can choose to go. There's not a wrong answer here. The other thing I'd just be remiss if I didn't put out there was, so we got CBRS now, and CBRS, depending on what manufacturer you go with, probably you're not, a gigabit's going to be fine for, because they're going to tend to be, if they're dual radio, you're going to be aggregating 20 megahertz each over two radios. So it's a 40 megahertz worth of capacity, right? You can just do the math on the data rates. You're still well inside a gigabit in terms of max load, max PHY rate. But back to this PoE question, and I see that's pretty animated in the chat discussion. Some of these small cells are power hungry, and so 30 watts may not be enough. So that would be just one other reason to consider as part of whatever your next refresh is, looking at your historical purchasing pattern.
But I do believe the PoE and the multi-gig are two separate issues. I don't know if vendors purposely put those together on the upgraded switches, and maybe that's what's keeping the cost up. Just one comment that I wanted to have for Aruba HPE is, historically, as you went from a Wi-Fi 3 to Wi-Fi 4 to Wi-Fi 5 to Wi-Fi 6, HPE has tried to keep those costs the same to take that decision. Should I move to the next version out of the equation? And I just want to give kudos. I think that helps the process move forward when there's not a price differential for the next rev. I don't know if that's even possible, though, as we move into switch traffic.
Yeah, well, actually, I hate to correct you, but I think there has been a sort of general steady upward trend. I mean, it's not huge, but the products have had more and more things added to them, right? And different radios, IoT radios, and what have you. But 6 gigahertz is going to be a bit of a step function. I can't say much more about it, but there is a whole new radio along with the whole front end chain, there's filter components, right, because of the 5 gigahertz band proximity and so on. So the what it costs us to build the APs definitely is going up this time. But I appreciate the comment, and certainly we're trying to make sure we've got price points that work for everybody.
Well, I hate to call an end to this discussion. I think if people like this format, leave a little another post in the chat if you'd like us to do more. Thanks, Lee. Thanks, Peter. And definitely thanks, Chuck, for this idea of getting it together. It gives us a chance to have a little further discussion, more than we would have on just a little short Twitter message. So if anyone has another topic, idea, comments, go on Twitter, say what you like, what you don't like, and let's see if we can do this again. Any last comments from the panelists?
Yes. Hey, I'd be again. Thank you, everybody, but both the folks in the audience and the folks in the panel. I would be remiss if I didn't remind everybody. I think a lot of you know, probably have this on your calendar already, but Network Field Day is next Wednesday, and we start. I think Aruba, we're going first this year, so we start bright and early at 8 a.m. Pacific, and I think you do not want to miss that session.
Nice little hint drop there, Chuck. Thanks
And
for
a
that.
quick thank you from me as well, everybody. Appreciate it.
Yeah, thank you from me too. Really appreciate it.
Well, let's plan on doing another of these in the future. And thanks all for listening in and getting involved in the chat.